In this equation, in this example, you're asked to solve the equation tangent squared x plus secant x minus 1 equals 0. And I'm going to describe both the solutions between 0 and 360 degrees, and I'll show you how to describe all solutions, all of the infinitely many solutions to this equation. Okay, so starting this one out, the first thing is noticing that you've got two different trig functions in this problem. In general, it's easiest to solve the trigonometric equations, well, two things. One is maybe you can factor out one of those trigonometric functions. So like if there's a common factor of tangent x, like you may have seen in a previous example, pull that out and then write separate equations that each involve only one trig function. The other strategy is to use a trigonometric identity to rewrite this thing in terms of a single trig function. And so the identity that might come in handy here, well, you may remember that 1 plus tangent squared x is equal to secant squared x. Rearranging that, if we isolate the tangent squared, that's equal to secant squared x minus 1, if you just move the 1 to the other side. If we replace the tangent squared right here with this expression, then we'll have an equation involving only secant. And so that's just one step better than what you had to begin with. So I'm going to go ahead and do that, a little arrow. So the tangent squared will become secant squared x minus 1, and then we've got that plus secant x minus 1 equals 0. So now rearranging and combining like terms, so it's nice to have the squared term in front, and then the term with the first power, and then combine the constants here, so minus 1, so that's minus 2. Okay, great. So now we've got an equation that's quadratic in form. If you'd like to use the substitution, let u stand in for secant x, you can do that, and you don't have to write out that substitution if you don't really feel the need. And in fact, I might do this, I'm going to write this one up without the substitution. So let me just talk through that for those of you who feel ready for something like that. So if this were x squared plus x minus 2, then I know that I would put an x here and I'd put an x here to start out, if I have x squared in front. Since I have secant squared, I'm going to put a secant x here and a secant x here. As far as filling in this second position in each factor, I need two numbers whose product is negative 2 and whose sum, let me write this out. I know I haven't written it in the previous examples. So we want the product to be negative 2, and we want the sum to be the middle coefficient, positive 1 in this case. So two numbers that multiply to give you negative 2 and add up to positive 1, positive 2 and negative 1. If you multiply them, you get negative 2. If you add them, you get positive 1. So I'm going to write that here, positive 2 and negative 1. And it's always a nice idea to think through the foiling to just double check that we've factored this correctly. So secant times secant gives us secant squared. Outside would give us minus secant, inside gives us plus 2 secant, so that's plus 1 secant, and then last gives us minus 2. Okay, great. Now we should set each factor equal to 0. I'm going to get well, no, we can go ahead and do that here. So secant x plus 2 equals 0, or secant x minus 1 equals 0, and then move the constant to the other side. Secant x equals negative 2, or secant equals 1. All right, now I do need a new page, clearly. Okay, so just rewriting. Secant was negative 2. Right, or positive 1. Opposite signs from when we factored. All right, so it's hard to think in terms of secant. Sine and cosine come most naturally. Remember that secant is the reciprocal of cosine. So if secant is equal to -2, then cosine is equal to the reciprocal -1/2. Similarly, if secant is x is equal to 1, then cosine is equal to the reciprocal. Well, the reciprocal of 1 is 1. If you want to think of that 1 over there as 1 over 1, then when you take the reciprocal, it's still 1 over 1. All right, so now you would grab a unit circle, which I did not paste in this time, but so grab your copy of the unit circle. We're looking for where, well, let me take the easy one first. Cosine x equals 1. So cosine remembers the x coordinate on the unit circle. So let me write here, cosine x equals 1. So the x coordinate is +1 right here. When, let's see, we wanted, we wanted degrees. Okay, so x equals 0 degrees here, or 0 radians. Okay, and that's your only solution. We don't want to, yes, you could say also x equals 360 degrees, but notice the strict inequality in the statement of the problem on that. 360 is just, it's basically, it's the same position as 0, so we don't want to count the same position twice, really, in that part A. Cosine is -1/2, so that's gonna occur twice on the unit circle, in quadrant 2 and in quadrant 3. Cosine x is equal to -1/2 when x equals 2 pi over 3, which we want degrees, sorry. So 120 degrees. I have to keep double checking, keep reminding myself. That's the quadrant 2 solution. The quadrant 3 solution is 240 degrees. Great. And so if we were just looking for the solutions, so part A, the solutions between 0 and 360 degrees, there they are. 0 degrees, 120 degrees, 240 degrees. Great. Now, describing all solutions. It's actually not that big of a deal in this problem. All you have to do is say, oh, let's take, for example, the cosine x equals 1, so this position here. If you added 360 degrees to that, there's another solution. And then add 360 degrees again, there's another solution. And then add 360 degrees again. You could also add -360 degrees. So the way we describe all of that is by saying plus 360 degrees times n, where n is any integer, positive or negative. And so I might not take the time in this video to write all of that out, but in part B, all you would do is write down all of these angles from part A and then add 360n. That's how you go from describing just the solutions in a specific interval, so just the solutions that you get from one lap around the unit circle, to describing all of the infinitely many solutions. Because again, and this is just one last thing for this video, think of the graph of cosine. So it does that wave over and over and over. If you're looking for when is cosine, I'll just go back to the cosine x equals 1. That's going to happen infinitely many times. It's going to keep hitting 1 over and over and over. And the same with the -1/2. I mean, that's down here. It's going to keep hitting that value over and over and over. So there are infinitely many solutions, and this is generally how you describe them.